first example, it's a graph representing the temperature over a 4-hour period. Okay, so first of all, if this is a graph representing temperature over a 4-hour period, what would we label our x and y axis as in this situation as it connects to the data? X would be the, which one? Time or temperature, do you think? Time, and y would be the temp. Okay, so let's talk about the domain. What do we first know about the domain? So we're talking about time. What's one thing that doesn't work? Sam, you have to do? Negative time. So really, if I'm talking about the domain, right, time can only start that. So on this specific example, it's over a 4-hour period. So on this example, it would go to 4. But if I didn't talk about a 4-hour period, what do you know about what's happening here? Does this make sense that, let's say, after 10 hours, the temperature is negative 300 degrees Celsius? No, that doesn't really even make sense. So when we're talking about this, well, first of all, that's for sure 0. But it's going to go kind of to a number where it doesn't make sense anymore. Do I know that number? No, I don't really know that number. But eventually, this polynomial is just is not going to make any sense because it's going to go on forever. Okay? Does that make sense? Negative 300 degrees Celsius eventually is just not making sense anymore. Okay, so if you see that on the test, it's you having to discuss to me what are the problems with our domain. Okay? So first of all, our domain can't go negative time. Second of all, our domain eventually just doesn't make sense with the situation. Okay, make an equation. Okay, so we could use other letters like time or whatever, but I'll just go y equals some kind of coefficient. How do I write a factor when the x-intercept is at 1? X minus 1? What happened at that x-intercept? It bounced. So that means I need a exponent 2. The next intercept is at 2. So x minus 2. And then the next intercept is at 3. So x minus 3. How do I figure out that? What am I going to do to figure out that a value? I'm going to plug in, I got to plug that point in. Okay, so I'm going to replace y with negative 12. And are you okay if I don't write the 0? I'm replacing x with 0. So I'm going to do this in my head. I'm going to go 0 subtract 1. 0 minus 2. 0 minus 3. Okay? I put the 0 in though, right? You see it? I just put it in, but I didn't write it down. Okay, can you figure that whole piece out? What do we get there? This makes positive 1, and then 2 more negatives, so I'm positive 6. Therefore, a is negative 2. Did you know that a was already negative when you started this whole thing? Because look at the shape of it. It's a W upside down. So A was already negative, I knew that. Okay, so here's my official equation. Okay, so every time you write me an equation, you better have all your factors and your A value. Okay, question C. Find the temperature after 4 hours. Okay, what should I do with this? 4 hours, is that, in our case, is it an X or a Y? It's an X. So if I know X is 4, what could I do? Plug it in. So at 4 hours, I'm going to go, the temperature equals -2 times 4 minus 1 squared, 4 minus 2, 4 minus 3. Okay, so I'm replacing X with a 4 because that's at 4 hours. Okay, what do we think there? What does that all come out to be? Negative 36? Guess we don't have a Celsius or anything. Okay, does that make sense with this graph? So here I am at 4 hours, right? You have a point way down there. 4, -36. Okay. Last question. Estimate the maximum temperature. Okay, look visually. Where on this graph do you see the highest temperature? In this zone, right? Okay, so this is an estimate question because you don't know. My calculus people, we're going to figure that out, but we're not going to do it in pre-calc. So estimate, if this intercept is at 2 and this intercept is at 3, what's a good X value to estimate with? 2.5. So I'm gonna guess. What? 4? No, the X value, like, I'm trying to think what's the X value-ish that would give me that? Okay, so you're going to do the same thing. You're going to do the same thing we just did here. So here we plugged in a 4, but now we're doing the same method but plugging in a 2.5. Okay, anybody have a number for me? It's obviously a positive temperature. What is this temperature? Anybody have a good one? A number? That they feel so confident in shouting out? You're going to make me do some math here? 1.125 degrees. Anybody else get that? Yeah. Okay. What if I asked you what the temperature was when we started, when the time started? What's the starting temperature? -12. The temperature at the start was -12. And then what happened? it warmed up, and then it cooled down, and then it warmed up, and then it cooled down and didn't warm up again. Okay. So here's my graph, if you want to see. So applied people, polynomials, there's my graph. So for me, I can just go 2.5, the temperature was 1.125. Did we hit the highest temperature? Not quite, but we estimated. So you don't know how to do this, but I can. What's the highest temperature? So it's between here and here. The highest temperature actually got to 1.24 degrees at 2.6 hours. Okay? But we were estimating. All right. Is that good? So you'll have one of those on the test. Okay, and the other question is a box volume. Okay, I gotta go kindergarten teacher here on you. Okay, so I have just a normal piece of paper. Here's what's happening. I'm cutting a corner out. Okay, like that. And now this corner, I'm going to repeat. And I'm going to cut the same corner out. Okay, and I'm going to do that out of every single corner. The same amount. Do I know? Did I measure that? No, I didn't measure it. I just cut it. But it's the same corner. Okay, so this paper, what's the paper dimensions? This is like 8, 8.5. We'll just say 8. No, this is 11 by 8, right? Inches, something like that, close. Okay, so pretend this was 11. And I fold this up and I make a box. You've probably done this before, right? Okay, so that side started at 11, right? And I cut, I'm going to call it X amount off because I don't know. And I cut the same amount off. What is the new length of that side of my box? It was this long. It was 11. And then I cut how much off? 2x. Because I cut x off and x off. Does that make sense? So this side was 8. Now it is 8 subtract 2x. Does that make sense visually? Okay. So, okay, our situation was we had a 6 by 6 paper or metal, and we cut off corners. So that little square, a square corner was X that cut off. Making the new dimensions 6 subtract 2x, right, because I cut off x and x. And the new dimension here, also 6 minus 2x. Okay, so we're going to talk about the volume of this box. So how do you do a volume of a box? Anybody know the generic formula for a volume of a box? Have you seen that one before? Length times width times the height? Okay, so the length is 6 minus 2x. The width is 6 minus 2x. And look at my box. What's the height? It's x, right? Because if I cut x off and then I fold it up, You see that that height is x. Okay, so write the equation for volume. Done. Model the equation with a graph. Okay, so what's the x-intercept? What's the x-intercept in this bracket? So I'm trying to set this to 0. I want that to equal 0. So if I add 2x, 6 equals 2x. X will have to equal 3 for that bracket to be 0. Okay, this is also 3. It's a repeated one. So on my graph, what's occurring if that repeated twice? Bounce. And over here, what's this x-intercept? 0. Do we understand the generic shape of this graph? Cubic, positive cubic. So it's going to look like that. Okay. So 1, 2, 3, and 0 are your x-intercepts. And we need to bounce at 3. Okay, on this one, I do not know any y values to specifically go to because my y-intercept is 0 as well, right? Okay, discuss the domain. Okay, so first of all, tell me about this part of our graph. Can I have that part of our graph? So this is x, so this is representing the amount that I cut off. Can you have a negative cut off? Can you have a negative volume? No. So this part of my graph won't even work. From here to here, what about this portion? Do you think that's good? Yep. What about the third portion? Think about x. Can x be 4? No, why can't x be 4? Because if you had a 6 length and you cut 4 and 4, what happened? You would have nothing left. You would have negative of a side length, which doesn't make sense. Okay, so the domain, I can go from here to here. Now, 0, does that work? Exactly 0? Can you cut off 0? If I cut off 0, what would physically happen? You would just still have a paper that's flat. You wouldn't have anything to fold up. So 0 doesn't work. So I'm going to put a round bracket on it because I can be as close to 0 as possible, but it can't be exactly 0. This is a 3. Can I have exactly a length of 3 for x? No. Because what happens if you cut 3 off and 3 off? What happened to your 6? It's gone. Can you have a length of 0? No. Okay, so that's our domain. Estimate the maximum volume. So the highest volume will have occurred in this zone. So plug in x equals, what do you want to use as a good x value to estimate in that zone? 1.5? Okay. Some of you might plug in a few things and get a different, it's an estimate question. So estimate everybody see why I'm squaring that? Instead of me writing this and writing it again. See? This and this. I wrote it and I wrote it again. That's also the same as squaring something. Okay? So what's the highest volume this box is going to get to? It's an estimate, so approximately, I've got a 13.5 cubic centimeters.